All right, so today we're going to talk about lesson 7-1, compound interest. Compound interest is the way most banks and other savings institutions pay savers, you the people, who put their money into their accounts. Let's take a look. First thing we need to talk about is powers and repeated multiplication before we get into compound interest. A number having the form x to the n power is called a power. Okay? The whole thing is called a power. X to the n is called a power. N is a positive integer and describes a repeated multiplication. For example, 10 to the third power means we multiplied 10 by itself 3 times. So 10 times 10 times 10 is the same thing as 10 to the third power, which also equals 1,000. 3 to the fifth power is the same thing as saying 3 times 3 times 3 times 3 times 3, 5 threes, which is equal to 243. Okay, so this is a very valuable power that you need to have, and you're going to want to write this down. Okay, the number x to the n power is called the nth power of x. It is read x to the nth power, or just x to the n. Okay? In the expression x to the n power, x is what we call our base, and n is the exponent. So therefore, if you look at 3 to the fifth power, okay, 3 is the base, 5 is our exponent. Okay? In the expression 100,000 times the quantity 1.02 to the x, okay, which is what we're going to find here shortly, 1.02 is our base, x is our exponent. 1.02 to the x is the power. How is interest calculated? An important application of exponents and powers occurs with savings accounts. All of us like to save money. When you save money, you can choose where you want to put it. Of course, you can keep it at home, put it in banks, savings and loans associations, and credit unions will pay you to let them hold money for you. The amount you give them at the start is called the principal. That's very important. That's how much money you are giving that bank. The amount of money they are going to pay you is called the interest. Okay, that's how much money you make from the bank. Interest is always a percent of the principal. Okay, the percent that the money earns per year is called the annual yield. Let's look at example 1. Suppose you deposit P dollars in a savings account upon which the bank pays an annual yield of 4%. If the account is left alone, how much money will be in it at the end of the year? Okay, let's look at the solution. The total is equal to principal, that's how much money that you put in, okay, plus the interest. The interest in this case is 4% of the principal. Okay? Well, if interest is 4% of the principal, we have to take P, which is principal, plus principal times 0.04. Okay? Because we still have our principal, we're keeping the money that we put in there, but we're gaining interest. Interest is 4% of the principal. How do you find 4% of the principal? Of means multiply. 4%, 0.04 times P. Okay? Well, if you got 1P plus 0.04P, you are going to get out 1.04P, or which is equivalent to 104%. Because in essence, you have the money that you started with, plus you're gaining money that you got from the bank. Let's look at Quiz Yourself 1. If you deposited $1,000 in a savings account with an annual yield of 4%, what would you have at the end of the year? Okay? In this case, our principal is $1,000. Okay? Now, kind of like up above here, our annual yield is still our 4%. So, I'm going to take my principal times, and like I said, like we did up here, we're going to multiply it to 1.04. Because the 1 stands for the money that we're going to keep still. It's our $1,000. And then the 0.04 is going to be our interest. So 1,000 times 1.04 is $1,040. So that's saying after 1 year, we now have $1,040 in our account. Compound interest and how it's calculated. When the year is up, the account will have extra money in it because of the interest it earned. Okay? In our last deal, after 1 year, we had $1,040. That was a $40 increase over what we made from the start. If that money is left into an account, then at the end of the second year, the bank will pay an interest on all the money that is now in the account, the original principal and the first year's interest. This leads to compound interest. Compound interest is very good, which means that the interest earns interest. So as long as you keep that money in there, okay, that interest that you made from the previous year is going to make you money in the second year. And then whatever interest you made in the second year, you're going to make more money in the third year, so on and so forth. It's just a constant building of money that you are making, as long as you leave it sit in your account. Very important. Compound interest is interest that earns interest. Let's look at example 2, and I'll show you exactly what I mean. Example 2 says, suppose you deposit $100 in a savings account, upon which the bank pays an annual yield of 4%. Assume that the account is left alone in parts A and B, which means you will never take out any money out of that account. A says, how much money will be in the account at the end of 4 years? Well, let's think about this. After the first year, it is $100, that's my principal, times 1.04. Okay? I have the 1 because I'm going to keep my $100. The 0.04 is my amount that I gaining off interest. Okay? In my second year, I'm going to have the same amount from the previous year, which is all this, times another 1.04, because I'm going to multiply it times, I get all of this, plus this amount is going to be multiplied times 0.04. So that means for my third year, I'm going to have $100. And then it's going to be all this times 1.04. So for the fourth year, it's going to be $100 times 1.04 times 1.04 times 1.04. I got 3 of them. I need one more, which is going to equal, because I'm only going to 4 years, which is going to equal $116.98. Okay? That's my answer to A. B says, how much interest would you earn in 4 years? Well, if after 4 years I have $116.98, I need to subtract how much I started with. How much did I start with? Well, my principal was $100. If I subtract $100, that means after 4 years, I made $16.98. Now, that's not a lot of money, but you also got to remember, I didn't put very much money in. I only put in $100. If I had more money put in, or had a higher interest, a higher annual yield, okay, I would make more money. Moving on. Looking at the pattern in the solution to example 2, at the end of t years, there will be 100 times 1.04. Remember, we kept on multiplying by 1.04 to the t power. That means it could have been 4 years, could have been 5 years, could have been 20 years. Okay? By replacing 100 by p for the principal and 0.04 by r for the annual yield, they came up with this general formula, which you need to memorize. Okay? You need to memorize the compound interest formula. You're going to want to pause now and write this down. Okay? The equation A, which is the amount, is equal to P times the quantity, 1 plus R to the T power. Okay? P is the principal, R is your annual yield, and T is in years. Okay? You got to make sure T is in years. So in essence, if they told you that you only kept it in for 3 months, 3 months is equivalent to how much of a year? Well, 3 divided by 12. Why divided by 12? Because there's 12 months in a year. So 3/12 is 1/4 of a year. So if they give you a problem that it gives you in months, you got to make sure that you convert months to a year. We all know 6 months is equivalent to 1/2 of a year. Okay? Very important equation. Let's use this equation in example 3. Says when Jewel was born, her parents put $2,000 into an account for college. What will be the total amount of money in the account after 18 years at an annual yield of 5.4%? Okay? Using our equation. Okay? A equals, that's the amount. Okay? P, in this case, is $2,000. Our R in this case is our percentage, which is 5.4%, which is equivalent to 0.054. Just changing a percent to a decimal, you move it 2 places to the left. Okay? My t in this case, it is in years, and my time is 18. Okay? So I'm going to plug those in. P is 2,000 times the quantity. 1 plus 0.054. And t is 18. Which is equal to 2,000 times 1.054 to the 18th power. Now, you have to remember your order of operations. You have to do this first. 1.054 to the 18th power. Once you get that, then you multiply it to 2,000. And my answer is going to be $5,154.19. So, your parents put in 2,000 right away for you. Okay? When you were born in 18 years, you basically have gained $3,100. Now, is that a big figure to go into college with? Not really. But if you let that sit there in the accrue until later on in life, you're going to have a lot more money. So I just wouldn't take that out yet. I would leave that in there. Okay? Maybe if your parents had more money when you were born and they put that in there, okay, maybe you can have more money for college. Why do you receive interest on savings? Here is why banks give you interest on savings. Banks and other savings institutions pay you interest because they want money to lend to other people. So what the bank does is they take your money, okay, and they're giving you that small interest rate, okay, and what they're doing is they're loaning it out to other people at a higher interest rate and making money off of that. So that is why your bank will give you a small interest rate, because what they are doing is they are using your money to lend to other customers. That is why we have interest on savings. We'll see you tomorrow. Hope this prepares you for compound interest.